All right, yeah. So thanks for the introduction, Jess. So yeah, as she said, I am co-chair of the W3C Immersive Web Groups. These are the groups that make VR and AR work in web browsers. The name of the API is WebXR, and it's really cool, and it's been working in a lot of browsers for a long time. Sorry, Apple users, it's not quite there yet, but fingers crossed. But yeah, so try it out, and that's kind of what the theme of this talk is going to be. I just want to get you to build stuff with the API that I've spent the last 5 years working on. Please. So yeah, I work for the web browser Samsung Internet. Sorry, this is the bit that I get paid for. So I have to do this. It's an Android web browser. It's really good. You can find it on the Play Store. We are a fork of Chrome. We have slightly different priorities. We tend to focus more on like privacy, security, extensibility, customization. For example, we've built in ad blockers and enhanced tracking protection. It's really good. We also have a lot more users than you'd probably expect. Actually, before this talk, had anyone heard of Samsung Internet before? Ah, that's nice. Okay, more than usual, which I guess it means I'm doing my job right. So yeah, we have a few main differences from. Okay, actually, of you developers who put your hand up, who tests their products on Samsung Internet? Oh, that's sad. Okay, so yeah, the rest of you should also test your product on Samsung Internet. We have like 500 million users, and we're like 7% of all mobile browsing goes through Samsung Internet. So you should test in us because we're not quite exactly the same as Chrome. And also good browser, so try it out for yourself. It's good. Anyway, onto the real stuff. So yeah, here is a demo of what. Is that playing? Oh no, is there no Wi-Fi? This is so cursed. Ah, damn it. All right, well, you have to try it out for yourself later. It would be yeah, that's definitely not playing. Oh, I'm so sad. Anyway, this would be a really cool demo of an augmented reality roller coaster. You build it yourself and then it runs. The URL for it, try it out. And my talk today will be showing you how that was built with WebXR. So WebXR at its core is an API designed to access the sensors and displays of immersive hardware. By that I mean like virtual reality headsets, like the Oculus Quest, augmented reality headsets like the HoloLens, or your normal smartphone. Again, sorry, iPhone users. There is a polyfill, but the polyfill doesn't work for augmented reality, only virtual reality. So borrow a friend's Android. But yeah, it's in Chrome, Samsung Internet, and yeah, it's cool. Obviously, Quest browser on the Quest and Edge on HoloLens. It works really well. It's been pretty stable for a while now. And the way it works is that using the API, you can get the sensor information from the device. So you know where various tracked locations are, like controllers, the user's head, various positions you've asked it to mark in the real world. And it will give you those positions. You then use that information to render a WebGL scene from the user's point of view, sticking various virtual objects at the various points you've tracked. And then you send that to be displayed on the displays of the device. So many devices, the same displayers will have the same display for the XR display as the one, like the normal computer one. Like a phone, like if you can do augmented reality on the phone, it'll be the same display, same on the Quest. But if you've got something like a computer plugged into an external headset, it will display it on the headset screens. So the user sees it when they wear the headset, and it will run at the frame rate of that device. It's kind of cool. I mentioned WebGL a few times just now. This is a API that's designed almost entirely to work with WebGL. Our integration with HTML and CSS is a little bit lacking at the moment. But WebGL is really, really powerful. Unfortunately, it's super verbose. So most people dealing with WebGL will use some kind of library. And that's why I'm going to introduce AFrame. AFrame is a really useful WebGL library. It's really powerful. It's a web component wrapper around the library 3JS. 3JS is a very long-standing, well-respected JavaScript API for WebGL. Sorry, JavaScript library for WebGL. But because it uses web components, it provides you with a whole suite of custom HTML elements that hook directly into WebGL under the hood. And then you end up with writing HTML, getting VR and AR ready 3D scenes. It's really fantastic. But it also has a really powerful API. So you can write your own components that hook directly into 3JS. So not only do you get like the power of being able to just write some markup and get rid of all the boilerplate code and get something working, you also get the power of being able to use the more advanced JavaScript API underneath. And if you make your own custom components, you can then share them around, put them on GitHub. Other people can use them. You can reuse them easily in later projects. It's a really nice way of working. And to be honest, what I use most of the time because of that. Even though I have doing this for so long, I use 3JS first. So yeah, here is the I swear this isn't the thing. Anyway, so this is the AFrame boilerplate. If you go to the AFrame docs and see the hello world, this is what you'll see. So this is the whole HTML file. You have a JavaScript library you import, which is the AFrame one, and then it's given us some new elements. So we have the A scene element. This is like the global element that wraps everything. So it gives you the container in which you use the new custom elements. Any global configuration usually gets put as attributes on the A scene element. We also have the A-box, which is a box. And we put it at a position like -1 to the left, half a meter up, and -3 meters away from me. So that ends up being into the screen because the coordinates are X, Y, Z, where X is across, Y is up and down, and Z is out of the screen towards you. Angles are in degrees, but get converted to radians under the hood. So you can work in degrees rather than radians, which is kind of nice. All of these items are like pretty huge. Like the default size for a box is a meter by a meter by a meter. The sphere is 1.25 meters radius. So these are all pretty big items. There's a cylinder, a plane, and a sky. And so the sky is just like a giant inside-out sphere, which they've colored gray. And it kind of gives you what you'd imagine from this. So you get a cube, a sphere, a cylinder. It's placed on a plane inside a big gray background. And this is already capable of working with virtual reality and augmented reality, like out the box. Unfortunately, if you were to put it into augmented reality right now, what you would see would be exactly what you see on the screen right now, because you would still see the sky. So the first thing we need to do is make the sky invisible when we enter augmented reality. And so there's a component in AFrame called hide on enter AR, which hides elements when you enter AR. It's pretty well named. And it's really useful. So if you have any items in the background, so if you want to build something that's like virtual reality and augmented reality, then any big buildings or background objects, you can just hide them with this component, leaving just the bits you want the user to place in their environment. But this looks a bit terrible. Like, this is the worst example of augmented reality I've seen because it doesn't anchor to anything in the real world. It's just floating there on the screen. Like, it might as well just be a sticker. And so what we want to do is place stuff into the user's environment. Does this video play? This one works. Anyway, that's good. So yeah, the AR hit test component is what we're going to use this. But the first thing we need to do is we need to make the objects smaller. Because like I said earlier, the objects were many meters in size. Like the sphere is 2.5 meters tall, um, which is like, I live in London, and I do not have 2.5 meters worth of space in any room in my house. Um, so yeah, I made the items a fifth their normal size, and I put them in a containing object, this A entity. So like the A entity is like the div of AFrame. So I put them in that, I shrunk that container object, and I told the AR hit test component on the scene element to target that object. And so what the AR hit test component does is that when I tap on the screen, it sends out a virtual ray into the real world, and where it hits a real object, it then returns that location and the orientation of the surface. So and by that, what I mean is like, I can place it on the floor, or in this case, this piece of furniture, or I could place it on the wall or a ceiling and it would align with the surface, which is a really powerful ability. The other thing I did, which is like a very minor thing, but if someone was following along and coding this themselves, I also added a camera element, which normally you get by default out of the boilerplate. But by adding it, is saying I'm going to take control of this now, and I made it a lot shorter because I shrunk all the elements. Otherwise, it's a bit weird when you look at it in VR and then there's all these tiny elements and they're like miles away on the floor. So the next thing you want to do is, as an added level of realism, is to match the real lighting from my environment. This actually photo is a really bad example because I took it at like 11 in the morning on a really bright day when the sun was coming in. So it makes them look really blown out, but it's because everything in my apartment was really blown out with bright lighting. But yeah, so the reflection component is what handles this. So it uses the WebXR lighting estimation API to generate an environment map of my apartment, like what the camera sees. It's kind of low resolution, so you can't really use it to get a camera feed of the user's environment. But it is really useful for giving the illusion of reflections in a shiny object. It also works out the direction of the main light in my environment and its color, so that will always match. So if I turned on like a purple light somewhere, the light of the AR objects would also become purple and from that direction. It's really cool. It's probably one of my favorite APIs because you literally just add this one line of code, and when you place augmented reality objects, they just blend seamlessly into the real world. It's kind of cool. The shadows is like a little bit more complicated, so I'm not going to go into how they work. But I'll tweet out a demo soon of how to do that nice and easily. Because it does look really cool when you have virtual objects casting shadows onto real objects. Like it's kind of fun. But yeah, so in the demo earlier, I had this roller coaster where it was these tracks going around. And yeah, you probably want some 3D models for that because not everything is made out of like primitive cylinders and spheres and whatnot. I made these myself. Well, I made most of this myself. The people in the cart I downloaded. This is about the extent of my 3D modeling abilities. And so you, like me, will probably end up downloading 3D models because producing 3D models is a skill that takes years to develop. So yeah, this is where I get quite a few models from for a lot of my scenes. Polyhaven is super cool and amazing. All of the assets on there are Creative Commons 0. They're ready to use on the web. They have a photorealistic aesthetic, and they're incredibly well optimized. Another one I like to use a lot is Sketchfab. Sketchfab has like 100 times more models. It's huge, massive community, really active. It's really fantastic. There's a mixture of ones you can purchase and some which are Creative Commons. But the models will probably be in a variety of different styles. You've got to find one that matches your scene. and they probably won't be as well optimized. So you may have to like download them and open them up in Blender and tweak them, like optimize the materials and the textures. But it's a really good resource for finding interesting models. And the last one I want to mention is the Permangerous Market. These ones are really good. They're even more optimized than Polyhaven. These are all created like CC0 or CC by attribution. They have a nice like low poly style aesthetic, but they are extremely optimized. Like a lot of these are tens of kilobytes in size, whereas the ones on Polyhaven tend to be around like hundreds of kilobytes. And you probably don't want to be going too much above that, both because of the download time, and also if you've got like giant textures or loads of polygons, you're going to be really start slowing down people's devices, and performance is incredibly important in AR and VR. But yeah, so if you want to search for models, generally the term to add is like game ready, because game ready assets tend to be ready to use straight out the box. But yeah. So once you've got your models, by the way, if you did want to use the models I used for this, like they're on my GitHub, they're pretty terrible. I don't know why you would, but they're there. I mean, if you literally wanted to reconstruct this demo I'm talking about, you could. So to use it, you add them as asset items in the AFrame assets component. And what this does, it pre-downloads them before the scene starts, giving the user like a really good experience. They're not like watching items pop in as they load. And then you use the GLTF model element in order to tell it to where to place these elements, and you can reuse them. So if I had a GLTF model with where 100 of them use the flag, it would use the same flag model again and again. It wouldn't download it once again per element. But yeah. But once you've got like your 3D models in, you're kind of in the situation where you want to do stuff that's more interesting than just placing 3D models. And that's why I really want to show you some of the third-party components, because although AFrame has a lot of the stuff built in, there is a huge community of more interesting, varied components, maybe for more niche things. And this is one which I'm going to demonstrate because it's probably the one I use in most projects. And it's called the AFrame environment component, because I'm often too lazy to worry about like what's beyond the main purpose of the project. And the AFrame environment component lets you very quickly define different sorts of environments. There's like a whole bunch of built-in ones, and you can customize them however you need. And it's just a quick way to give lots of like feeling to your projects. The details for it are on its GitHub. It's usually the case with all of these components. They'll just have their instructions in their README and some sample code. In this case, I replaced my sky with the floor with this component, which I also made hide on enter AR because it's something which I don't want to see when I'm in augmented reality. There's a whole bunch of useful AFrame components. So if you seriously get involved in working with AFrame, this is a good slide to take a photo of, or I'll tweet it out later. I'm just going to list off some of these. So the AFrame environment component I just mentioned. AFrame Extras has just a bunch of really useful little utilities for dealing with virtual reality stuff. The AFrame physics system is probably my favorite. It's a bit difficult to use to the point where I wrote a blog post about it, which you can also read, because adding physics to like virtual reality and augmented reality experiences just makes them feel so much more engaging. Like having virtual balls bouncing off real walls, or in virtual reality, picking up objects and throwing them around just makes them feel really good. It makes you feel like you're an actual part of the experience. So adding physics to stuff is like, it's a little bit expensive, it's difficult to do, and but once you're used to it, it's incredibly powerful. There's a component I've been working on recently called Handiwork. And that's with working with the WebXR hand tracking API. So it can tell you if the user is making certain poses with the hands, like if they're making fists or pointing or flat. So it lets you hook into like them as events. So you can listen for users trying to pick up objects or letting them go or pointing at something to interact with it, which is a really neat way to work. And one that's really useful for virtual reality, but not augmented reality, is AFrame blink controls. So this is for teleporting. Like teleporting in augmented reality doesn't make sense because you can't literally teleport. But in virtual reality, it's hard to actually walk places, especially for in a room with a room of limited size. Because you'll be in some huge boundless world, and so teleporting is often the way you do it. So this lets you point your controller or your finger at somewhere, and then you can just teleport over there, which is kind of nice. And the AFrame Super Hands component is just a really useful component for letting you pick up objects. But all of these have instructions on their GitHub, and definitely check them out. Anyway, back to the project at hand. I've been talking about random AFrame stuff for too long. So we have our 3D objects, and we want to make a railway track that goes around. So I made a component for that a while ago. You'll probably never need to use it unless you also want to make a railway track or a road or some other thing that's copied around a curve. And that's what this does. So you define a-curve-points and inside an a-curve, and it will draw a line between them, and it will copy a 3D model along that line. And that's what we did here. So I've got the railway station, where I've put some curve points in the railway station, so it travels along the railway track in the station. And then I've just defined some other points that go in a loop. And it's kind of neat. Oh, and I put some flags on some of the points so you can tell where they are, and it makes them look nice. And it just kind of works, which is kind of pretty neat. So adding the animation. So what we want to do is that we want to make the cart move. So to do that, we're going to write our own component. Like no one's, as big as the AFrame community is, no one's made a specific component for making a roller coaster cart move. Maybe one day I'll get that big, but for now, we can write our own component, and I'll show you how to do it. So this is the AFrame component lifecycle. So when you're defining your own component, you want to run this code at certain points. So I've left all the functions blank for now, but I'm defining a roller-coaster component, so I add it to any element to use it. And I've given it, I've told it that it has a curve property, which is a selector, so that I can select any curve in the scene in case I had multiple roller coasters, and then I can do something with them in the later functions. So the first two functions, init and update, are how you kind of set your configuration. So init runs once. It runs once the component is first instantiated. This is where you can like bind some things, set some variables. And update runs every single time the data changes, and also at the start. So in this case, if they change what the curve is, we stop listening for the events on the old curve and change it to the new curve. If you make any changes, we reset the speed just in case something weird is happening, and just kind of stop some bugs later. I'm just going to hand wave a lot of this because it's super detailed and you don't need to know it. Like, unless you're literally building a roller coaster in JavaScript, you don't need to know this stuff. So the tick function is the one that's like where the magic of a lot of stuff happens. It runs every single frame, and that's not like every 60 milliseconds. That's every frame of the virtual reality or augmented reality device, which can sometimes be up to 90 or 120 frames per second. So generally, your tick, like the time you've got per tick, is a lot shorter. So don't do anything too heavy in these. And in this case, all I'm doing is I'm moving the cart according to a particular value. And I increase that value each tick according to its speed, and I change the speed according to how much the curve goes up or down. So if the cart goes down a bit, I speed it up. And there should be a cool demo, but I don't think this is going to play. Shucks. The demo gods have cursed me today. So yeah, that's really, really annoying. Anyway, it works. The cart travels around the track. When it goes up the hill, it slows down. When it goes over the other side, it speeds up. It's pretty cool. So yeah, now we've got the basic functionality. That's all standard doing stuff in 3D. It's not what I came to talk to you about, which is augmented reality and adding interactivity. So what we want to do, we want to add new curve points or change the curve based upon the user's input. And so what I can see here is I press Control-Alt-I, it opens up this nice inspector, and I can see that when I move the curves, when I move the curve points, the track updates accordingly, which is what we want. I mostly showed this to you so that if you're working with AFrame, you know the command Control-Alt-I opens up the inspector. It's like a little bit hidden, but super useful. But that just seemed like a good way to get it in. So these are the events we want to listen for. So when the scene element fires the enter VR event, that's when we know we've entered some kind of immersive state. Annoyingly, it's enter VR, which also applies for AR. So you have to, there's no separate enter AR event. So it's just enter VR. Anyway, so once you've entered virtual reality, you can check if it's augmented reality. And if it is, then we're going to remove all of the curve points aside from the station. This is just, and as you can see, this is normal HTML DOM. Sorry, this is normal DOM methods in JavaScript. This isn't weird arcane AFrame stuff. It's web components. It's normal set attribute, dot remove, that kind of stuff. Query selectors, which I'd hope you've got some familiarity with. And we set the attribute of the curve to open. So instead of being a closed curve, it's now an open curve. And we tell the AR hit test to start positioning the station. So this now lets me place a station in augmented reality. Not much else though. All it does is let me place it again and again and again. So what we want to do is we want to listen to some of the events fired by the AR hit test component in order to build stuff. And this has 3 main lifetime events. So it's the AR hit test start. So the device has the capability of doing some kind of hit testing. And so you should maybe let the user know. Then there's AR hit test achieved. So this has finally warmed up the augmented reality systems underneath, and it's worked out a position in the user's real world. And then finally, we have the AR hit test select, which means the user has tapped on the screen and selected a location. So when this happens, you can do something with this information, and it tells you the position and orientation of where they clicked, like position orientation of where they clicked in the real world. So if I'm holding my phone like this and tap here, it will tell me a position on the stage over there. So that's where we're going to do all of our work. And this is super boring JavaScript DOM events. So we get the position of where they tapped, and then we make a new element. We give it an ID. We give it a GLTF model so that it has a 3D model attached to it. We set its position to be equivalent to be the X, Y, and Z of the position we got from the API. And we add it to the document. And because AFrame is based around this, it will know to instantiate a new element and update it and add it. It takes care of all of that for us. And then we tell the AR hit test to start positioning this new element we've just created. And so what happens is we add the station, this fires, it creates a new point which we can place. When we add that point, it creates a new point, and it keeps doing that for infinity, which is like, it's okay. Like, we've got an infinitely running thing where we keep adding points, and but roller coasters don't just go endlessly and then finish into a void. They loop back up to the start. And so we want the user to be able to inform us that they've finished. So we're going to do that. We're going to add some interface to it. So there is another WebXR API called the DOM Overlay API. And I mentioned earlier that WebXR deals solely with WebGL, but that was a lie. Sorry. There is one edge case where we can cram in some HTML and CSS, and that's the DOM Overlay API. So in phone-based augmented reality, you can give it an element, and it will stretch that element over the whole of the augmented reality experience. Like, basically, it's going full screen. And then you can put content in there. So in this case, I've added a title of roller coaster, and it appears on the device. Which, if you'd showed me that 2 years ago, you would have blown my mind because it was revolutionary. But to most normal web developers, showing them HTML elements on a screen isn't that exciting. But to me, it's really exciting because, like, it's an edge. Like, we're getting some declarative content into WebXR, which is really important because this is accessible. Any buttons or content you add here will be able to be read by the screen readers, and will be able to give feedback to people using like assistive technologies. So yeah, I think that's really cool. It doesn't work in headsets because the idea of something being full screen in a headset is kind of a bit fuzzy and nonsensical. Like, do you spread it over their entire field of view? Do you make a floating window and put it in there? Like, it's kind of a bit weird. So we're looking at other APIs of getting DOM content into virtual reality and AR headsets too. But yeah, so we're gonna add a button. So the button element is really handy because then it draws like a rectangle you can click on and fires events. I think that might be a bit too basic. You've all used button elements here before, right? Cool. No button elements? Do you use divs and then class? But yeah, like normal HTML. Like, again, normal HTML stuff. You click on the button. We hide the button because they've clicked on it. We don't need to use it anymore. We tell the curve it's now closed, so it can join back up to its starting point. Like, we find out what the next element was going to be, and then we just remove it. And we disable the hit testing because we don't need it anymore, and it like saves some power, and it's done. We just it's complete. And this is, I was going to say, compared to the example I showed you earlier, this isn't everything it can do, but you never saw that example earlier because the video failed. But yeah, this isn't everything. My finished one had like an undo button and looper loops. But hey, all of that stuff is boring for me to tell you because, again, it's normal web development. So if you have normal web development skills, you can extend them into working with VR and AR like this. I hope this has kind of shown you like some of the things you need to think about when building augmented reality games. Like AFrame is really cool. Recommend you try it. And thank you so much for listening. So I've been Ada Rose Cannon, while still am Ada Rose Cannon. I've worked with Samsung Internet. I hope this has inspired you to make something. If you want more information, like tweet at me, tweet at our team, or email us if you prefer. Feel free to reach out via Twitter or email. I'm on the veto thing after this, or just come find me. I'll be wandering around. Yeah, thanks.